Hey guys, so today we're getting back to doing, well, having videos of me doing your homework problems. And there has been a bit of a hiatus, and if you're not in the current year, 2017, 2018 year, then there's probably not a hiatus, but I had some licensing issues, and so I have since got them resolved, and I apologize if any students were negatively affected by my absence of homework videos. But I'm just going to go ahead and do the worksheet that I assigned for you for 5.6 day 1. And this worksheet involved quadratic function transformations, as we can clearly see in the title. Quadratic function transformations. All right, good. So given the following transformations of the quadratic function, f of x equals x squared, we're missing a squared here, graph the function and list the following transformations: minimums, maximums, and vertex. So the transformations is anything besides x squared. So anything besides this, x squared. Anything besides that is a transformation. So that means this plus 5 here is a transformation. That is the only transformation here. And the plus 5 within the parentheses moves your graph to the left 5. So that's the only transformation. So the typical parent function looks like this. This is what the typical parent function looks like. Whoops. That's what the typical parent function looks like. It's going to move to the left 5. So moving to the left 5, you got 1, 2, 3, 4, 5, and it's going to look like this. Whoops. Kind of hard to do with the pen in my way. I guess something like that. Now, the minimum value on a parabola that opens up is the vertex here. And so this minimum value is 0, aka -5, 0. Books change their minds as to how they want this presented. I'm a fan of the y value 0, but sometimes they want the ordered pair, so I'm going to put both. The maximum, however, this parabola is going to go up and up and up and up and up and up and up forever. So there's not going to be a maximum, so there'll be none. And then the vertex is -5, 0. Moving on. If you look here, number 2 is -2x or -x squared minus 2. Well, there's not a number in parentheses, so it's not going to move left or right any. However, the stuff that is going to affect the graph, so this is the parent function, x squared. Everything else, all of this, the negative and the -2, move the graph in some way. They do something to the graph. So the negative sign here gives us an old raxa, is what I call it. And this means a reflection about the x-axis. R-A-X-A. Reflection about x-axis. Then the -2 moves down 2. So those are your two transformations. The -2 at the end moves down 2, and the minus in the front, if your x squared is negative, that's going to reflect about the x-axis. So let's go ahead and graph this. The parent function looks like this, something like this. And so ours is going to move down 2 and reflect over the x-axis. So down 2 and flip over the x-axis. It looks something like this. And the minimum value, in this case, on a parabola that opens down is going to be none. None. Because minimums are the y values, right? The lowest y value that gets touched. And the graph is going to go down forever. So there's never going to be the lowest number because you can keep going down forever. Maximum, on the other hand, would be this y value here, which is -2. And you could aka that to the intersection, or the vertex, which is 0, -2. And the vertex is 0, -2. All right. Moving on to number 3. You've got 3 and minus 4. These do things to your graph. 3 is a vertical stretch by a factor of 3. And the minus 4 is right 4. So this piece does this, and this piece does this. So parent function, once again, doesn't look like that. Looks like this. Looks like this. Something like that. And then we're going to move right 4 and vertically stretch. So it's going to make it a lot more narrow. So right 4, 1, 2, 3, 4, and make it a lot narrower. So like this. Whoa, whoa, whoa. Dang, so hard to do. There you go, that'll work. It's like very narrow comparatively. The minimum is the lowest value, and that's 0 here, aka 4, 0. The maximum is none, because all parabolas that open up don't have a maximum. And the vertex is this point here, which is 4, 0. Now, let me switch to the next slide here, because I'm having to break this down into several different pieces. So next up, we've got this one. Okay, so number 4. We've got the 1/2. So I'm going to highlight everything that changes the graph. The 1/2 changes the graph. The +1 changes the graph. And the +3 changes the graph. So the 1/2 is a vertical shrink by a factor of 1/2. The +1 moves it left 1, and the +3 moves it up 3. When you're in the parentheses, that's moving left and right. When you're outside of the parentheses, it's moving up and down. So the parent function looks like this to begin with. It's going to move left 1 and up 3. So left 1, up 3. I'm going to erase this. From the anchor point, moves left 1, up 3. And then it's going to vertically shrink by a half. So it's gonna drop, like all the values are dropped down, so it's gonna look wider. And I'm not too picky on how wide you make it, just so long as it is wider. That's not even crossing the vertex. That'll work. Okay, the minimum is this y value here, which is 3. aka 0, wait, whoops, not 0. Sometimes they want the individual point, so 1, 3. This is the value I want, though. I just want to point that out. The y value is historically the value that gets cared about. The maximum is none, and then the vertex is 1, 3. Moving on. State the transformations of the given quadratic function. Don't have to graph it anymore, just state the transformations. So this should be pretty simple. The 2 does something, and the +1 does something. You guys should be able to tell me at this point what these do, right? You guys need to be doing your own homework, for goodness sake. The 2, and any number being multiplied by your x squared, is going to vertically stretch or shrink your graph. So the 2 is going to, since it's bigger than 1, is going to vertically stretch by a factor of 2. And the +1 here is going to go up 1. Simple enough. Here, this 1/3 is going to be a vertical shrink by a factor of 1/3. Then the -2 is going to move right 2. Okay. And the last piece of the puzzle, we're trying to move through this pretty quickly here. The 1/3, wait, did we just do this? Didn't I just do this? I just did this. The +7 and the +3, you tell me what they do. You should say left 7, up 3. And that would be correct. The number inside the parentheses moves left and right, outside the parentheses up and down. Then here, the negative is a reflection about x-axis. The negative does that. The +3, just like the +7, moves it left 3. The -6, just like the +3, moves it up and down, but this case it moves down 6. Here, just negative x squared, well, that's just a reflection about the x-axis. Here, 16 vertical stretch by a factor of 16 and then down 3 because your minus 3 is outside parentheses. Here you got a whole slew of crap doing to your graph. Your negative is a reflection about the x-axis. Your 1/2 is a vertical shrink by a factor of 1/2. Your 6 is moving left 6, and your 8 is moving down 8. Man, my eyes hurt, guys. I have been recording like all day long. All day long. You guys are getting the end of it as you normally do on your homework videos, where I'm at the very end of my patience, and I'm just exhausted. Okay, that's fine. Hey, I set up my camera, but I'm not using it. I don't have my green screen up right now, and I have my Twitch jacket on, which I should just make sure not to show. I don't want my students knowing that I have a green screen and a Twitch jacket, but I guess I just told them. Whatever. Who cares? You guys don't care. All right, so there's your homework assignment. Welcome back for those of you who are in the 2017-2018 year. I've been having some downtime, but it is what it is. Hopefully you're using these to check your work, not to do your work. All right. See you guys on the next one.